Hello friends! Today we are going to see how to debug a target endpoint not reachable issue, which essentially means that you got a one-liner from someone that okay, if I have a server and I have a downstream dependency, let's say a payment gateway want to go and connect to that payment gateway endpoint, I'm not able to do it from my server. This is a tricky issue. We are going to discuss many options that are available, and eventually we will see how we can come out of it. So before we begin some of the networking basics, just a recap of things. Many of you may know this. So what is an IP address? We'll start with a 4-byte IP address because that is base, so which we can build up on top of what is IPv6, which is more prevalent these days. So IP address is a uniquely identifiable address for any endpoint that is connected over the internet. So it is 4-byte in nature in IPv4, and this typically looks like 10.0.1.2, for example. It is having an associated submit mask, which essentially allows the network packet only to travel to a given network, which that submit mask designates. For example, if I have a submit mask of 10.0.0.0, my network packet, when I broadcast or multicast, it will reach only to these designated nodes, not beyond that unless I configure some kind of gateway or router to go and communicate with external environment. And there also I can designate one single line point through which all my traffic can be related outside the network. Secondly, there is another concept called private IP range. I am talking is like all this related when you go and debug all these things. Private IP ranges are the ranges that are assigned by internet service provider where you don't need any permission or acquisition of IP address from external folks. And these are of typical nature, which is defined by the Internet Protocol Agency. And these are into the range of, let's say, this one at line number 1910.0, 172.16, and 192.168, and all of them can be used independently within your network. And that is what private IP address range looks like now. Similarly, there is something called live IP, which you need to acquire from your internet service provider. Let's say you take a new internet connection, or any server will have, which is internet accessible, needs to have the live IP, because that is the unique identifier that any router, any third-party machine will use to target your endpoint, though there are some layers on top of it like DNS and others, but that is what the main ingredient for any communication across the network, which I say over the internet, now come to IPv6, which essentially is an evolution out of IPv4, because we are going out of range for IPv4 and the number of devices are ever increasing. Typically of 4.2 billion, 4.3 billion is the maximum number of devices that IPv4 supports, so investify the need of IPv6, where they increased the range of IP address from 4 bytes to 8 byte, and that gave them a leverage where they can have the devices much more than what it was in the IPv4 section. Now I just pasted here some basic details related to what this IPv6 looks like, or how the designation or division looks like. So that the right to left, if I go the rightmost, 64 bits are for device identifier, and usually this device identifies being created by the MAC address of the Ethernet card. So each of your devices are connected with the Ethernet card, and they all of them have a MAC device ID with them, and this is what the 64-bit designator. So MAC usually is 48 bits in nature, so they pad for 16 digits in the middle and get the 64-digit identifier for your individual device. Similarly, these 16 bits are your subnet ID, which we talked just before, which will allow users to not go beyond the network for some kind of private IP packets that you're sending across the network. Similarly, this 40 bits are random bits, which we usually use to designate a network or a provider, a set of devices that a given network belong to. And then we have something like a prefix at the beginning, which designates different types of packets. Okay, so usually this is like a string, which is of 7-bit or 8-bit in nature here. What you're seeing is a 7-bit string plus there is a padding called L padding, which is one more bit, and this together 40 plus 16, or I say 40 plus 14, or 40 plus 24 indeed, are the bytes that designates the network part of it. So we have 64-bit here, and then 64-bit on the network side together forms 128 bits, and that is what the IPv6 range comes to now. Coming back to the topic, what are your first steps that one should take to check that the endpoint is reachable or not reachable, right? Because that is the one-liner, and you don't know where to go, how to start, right? So the first thing that comes to anyone's mind, if you have some background on the networking point, okay, there is a tool which is called ping.png that is available across any operating systems that we use, what we usually do is like we use ping and the endpoint address that we can use to go and see like if that is reachable via ping. Okay, so that is the first step any provider will do, or any debug will do, to start the debugging process. So that the first step, let's say, okay, I go and type here pingnow.com, and then you see that, okay, there is a network response here, right? So in this case, this is reachable, but in your case, it may not be reachable. For example, if I do ping and some hypothetical address 2030 and 177, it may not be reachable. And that is what you will see some point of time that, okay, that is why I am seeing a network time of the system, time of type of thing, while I'm going to hit my endpoint, which we were talking about payment gateway pattern. Now, this can have issues. I mean, a second thought as a debugger to this problem, you need to adopt, okay, is it because the network is not up, because the third party will say that my system is up and running, you are open to connect, but at the same time my system is not connecting to them, okay? So now the second thought, if this fails, you need to start and think around and see, okay, if I can use something else to check if my port or the target port that I'm targeting to reach out to that third-party server is reachable or not. And what essentially it means is I need to give not only the default port which ping uses, but the specific port on which it connects, right? So there are other tools like Telnet and Nmap, which you can use to check whether that Telnet or Nmap thing is opening a port connection or not. Okay, let's assume that as a next step that, okay, this port is open, and then we are able to make a connection to it, but still my server gives an issue, okay? And that is the next step, which we want to go and see and try it out, that what we can do to see that, okay, what are my next set of debugging steps that I adopted to see like, okay, if I can do something before I move further. Probably I just want to talk about one more tool that is of use to you, which is called Traceroute, and Traceroute or Tracert in case of Windows based systems, which most of the developers have, is another tool that you can use to check if your packet or network packet is getting lost in the hops, which essentially means that, okay, most of the time in the corporate environment is not like one endpoint interacting with the second endpoint without any intermediary, and these intermediaries are nothing but proxies and your gateway, right, as well as some kind of service provider nodes through which that your packet flows to eventually reach the endpoint. Right now, if your packet is dropped in between at any point of time in this overall gamut of things, then you need to figure out where this is getting dropped, okay? So probably if you go and run this command traceroute and give the endpoint ID where you want to go and see that, okay, how it looks like, right? So it will give you that which hops it is going, and what you're seeing on the right is the hop that you're seeing, right? Now from my side till the endpoint where we go and reach it is having a maximum of 30 hops, which shows like how the flow of packets going in right now. Again, let's imagine that this step is also through what should I do next to say that these things are not working, right? Then that's where I'm going to introduce, and most of the problem which I debugged in the past are originating from, okay, and they are nothing but proxies. So proxies are kind of your gateway, especially in the corporate environment. Or in current internet environment, I call it, or your gateways, through which you can interact with the external world, right? So most of the network admins of your company or other places where you work put certain kinds of rule which kind of traffic can go in out of my network and can come to my network. Both of these are configured with the help of something called proxies. Now coming back to the proxies, I mean one thing which we need to ensure that, okay, two things, maybe not one thing, is like you need to see that if your proxy address is configured properly or being passed properly before you create any kind of object HTTP client or any other variant of it to connect to the endpoint that you are targeting, which essentially means that on the server you need to configure at the time of a startup. Let's say take an example of a Tomcat, you need to during the startup you need to pass on this argument with -d, and then the let's say http.proxy address. This name can be anything, but this is the variable, and then your proxy's address, which should be in there, is a reason for it. Why people do this way and not other way around is because these are going to change over the period of time, and then we can use this mechanism to change it with just the restart of the server. Sometimes people prefer to pick this up from the configuration systems as well, so that we don't even need a server restart. But the easiest way is like to pass on from the command line parameter for the server startup time. Most of the time during the startup of a given server live duration, this remains same, and like in case it is seen, you can just restart the server passing on the new values, and it will take it from there. Right now imagine that this is also there for you, right? And you have entered your proxy address and the port which I just typed incorrectly here right now. What is your next step? Okay, still things are not working and what should I do? And that's where the next thing comes into picture, which says that, and then I will put this all in a location where you can see it in more detail. The next thing comes into the picture is about what should I do, right? I mean, because I have two nodes and both are not able to communicate despite I have passed on the proxy details. So first thing we need to ensure, okay, let me use some other tool through which I can ensure at least that these two nodes are in connection, or in connection they're working. And that's where my next thing comes in, which is something like curl, right? Curl, or Wget. These are some of the utilities developed which allows you to communicate with the endpoint, right? And that's where I have created one simple command, which I will just put up here example. So let's say if this is the endpoint, and all of them are fictitious, probably I can use directly this curl command to go and hit the endpoint which I am trying to enter, which you see what you're seeing on this part is the proxy configuration, which essentially means the proxy that my server is providing, and it may be the proxy that can go on the server side. So it is possible that the target server which you are hitting is also behind the proxy, and it is possible from where you are going is also behind the proxy. So on the server side it is called reverse proxy, because it is receiving the traffic from outside environment, versus from our side it will be called as proxy because it is going out type of traffic, right? So here what I am passing on is the proxy on the client side, which I am aware of it. Some things you need to be aware here is like this is the username and password. Let's say if your proxy is enabling authentication and you need to communicate with proxy with username and password, you can give your username password in this format. Preferred is like you convert this into base 64, which essentially means that in case of special characters, this endpoint which you are using for a proxy should not be broken, and that's why we need this to be base 64 format followed by @ symbol, and then the address of the proxy including the port at the same time we use for verbose output. And then this is the endpoint URL which you are trying to pick. For example, there is a user with ID 1 which I want to hit using curl, and if I just go and enter it, probably it will go and try that out. Because this is a fictitious URL, it will never work, but this is the common ground that we can take to ensure that, okay, if my proxy and my endpoint together are working fine or not, right? One thing probably now, let's move on and see that, okay, this is also working, right? What is my next step? What should I do to get to the next level? And see that, okay, what is wrong between these two nodes, right? Sometimes I mean just before we move to the next step, sometimes we run this curl from the developer machine, and sometimes we run from the end node from where this connection is getting through, right? And both of these steps are important because you need to debug from the node at which this issue is coming, not from the node or a developer machine. Sometimes it may happen that the developer machine is able to hit the target endpoint, but you may not be able to hit the target endpoint at that particular node, right? And at each given point of time when you see this failure in these debugging tools, you will have a probe that you can act upon. Okay, if my proxy is giving issue, if my endpoint is down, if my network provider is not loving, there is another thing that is your network firewall. Sometimes, especially in the corporate environments, network admin set up some network firewalls through which the traffic to a particular destination or traffic of certain types is not allowed outside the network boundaries, and at that point of time you may need to ask and go to your network provider or network admin to open the ports or open the traffic or tunnel for you to go and hit those endpoints. Moving on now, let's say that these things are also working, right? And what is your next target thing, right, which you need to figure out right now? Most of the ecosystem right now, what you see are behind some kind of, HTTPS-based connection, right? And usually we call it as TLS. And like this TLS has multiple versions, and probably you just need to explicitly have not mentioned the version, but you need to ensure that which version of TLS you are using on the client side and the target endpoint head side. See that if there is no mismatch between the version that you are using on the client side as well as on the server side, right? Second thing, most of this TLS works on something called a certificate. Certificate is a kind of token that is issued by a certification authority, probably less. Let's Encrypt is one kind of authority which you can go and search over the internet to see how they do this. But in order to be successful in this TLS part, one thing you need to ensure that you are passing on the right certificate, and there is no certificate chain breaking, which essentially mean that you first need to see that, okay, the certificate is indeed available to the server, if that is available, which essentially means that you need to go and check in your Java repo in case if you are using Java-based system, but this for entire set of providers irrespective of the language they are using, but specifically in case of Java, it is under the key store. There is a special directory where this key store is storing all the certificates that server is having access to, and through which it can go and communicate with an endpoint that we are targeting, right? Sometimes this key store is not used, and then again, this comes from configuration system, and the system leaves it on runtime using some mechanism, and then pass it as a part of a handshake, initial handshake, that TLS2. Right? So these are some of the starting points which you can use to debug your issues, and this is actually a journey, and it won't happen overnight, but I tried capturing as much as I can to ensure that you start on that journey of debugging, so that you don't feel that okay where to start from, because this is a lot of which I passed on, so take some time to absorb it, and start towards your endpoint. One more thing which I want to call it out. OpenSSL is another good tool which you can use for your debugging of your TLS issue. So OpenSSL not only generates certificates, it helps you in ascertaining that, okay, there is a breakage in the communication or handshake part, if there is a version mismatch between TLS and all that, but yeah, that is too big or broad topic to be covered in this point of time, but do take a note of it. Another important tool which you should be aware about in these kind of scenarios is something called Wireshark, and Wireshark is a network sniffing tool, which essentially means that whatever traffic, and as you know that there are 4 layers of TCP/IP protocol state, and what Wireshark do is it works at the lower level of the application layer and then sniffs your packet, which essentially means your IP-based IP layer packet, and use it to recreate your workload, which essentially means that it gives you opportunity to see what is going in and out of your machine. Sometimes it is possible to use Wireshark, sometimes not, and why I'm saying that. Wireshark is an installable tool. There may be equivalents of it where you can use it as well, but you need to have installers and you need to have admin privileges to run this packet sniffing tools. There are other packet sniffing tools also apart from Wireshark. You can equally use them to see that, okay, what is wrong with it. And that's pretty much for now. I pause, and we will meet next time. Thank you for now. Goodbye.